students, welcome to this session. So now I will discuss the topic demography and population control. So with this topic, I am starting the section 3, that is care of the vulnerable population. In this section, one part is on women and children and the other part is on other vulnerable population, that is geriatric population and occupational health, that is those into special occupation where there are some hazards. And in women and children section, I will cover demography and population control, the program, that is reproductive, maternal, newborn, child and adolescent health program, then family welfare, maternal and adolescent health and child health. So I'm starting the first topic, that is demography and population control in this section. So here I will discuss demography and demographic cycle, the commonly used demographic indicators and vital statistics, the prevailing population dynamics and measures taken for population stabilization in India. So this topic I have spread over into 3 units. This is the first unit, demography and its indicators. It covers CBME competencies 9.1 and 9.2. And in this unit, I will discuss definition of demography, then the concepts of population pyramid, demographic cycle, demographic dividend, then calculate the various population and vital statistics. So I start with demography. So the term demography was first used by Belgian statistician. So he defined demography as the mathematical knowledge of populations, their general movements and their physical, civil, intellectual and moral state. But basically, demography means the scientific study of human populations, and it is concerned with population size, the composition of the population in terms of age, gender, and distribution of population in space, that is the population density, etc. And also it deals with changes in the population due to fertility, mortality, and mobilization due to migration and marriage. So what is a population? It is a group of individuals that coexist at a point of time and they share a defined characteristic. So for the purpose of demography, this is the characteristic common is residence in the same geographical area. So there are 2 ways to enter a population, that is by birth and by in-migration or immigration, and 2 ways to leave a population, that is by death or out-migration or emigration. So this is the demographic process by means of which the population changes. So population is a dynamic condition and change in population happens due to these factors. So which is the demographic process, how it happens. So this is fertility, mortality, mobility, migration and marriage. So now I come to population pyramid. This depicts the demographic structure of a population. This is a population pyramid. So it looks like this, a pyramid. It is a double histogram with a common base. I have told you about histogram in the earlier session on statistics, data presentation. So histogram is basically multiple bars together. All the bars are together without any space in between. And this depicts the entire population. The length of the bar is equivalent to the size of that group, particular group. So here the subjects are represented by length of the bars, the number of subjects, and the women are on the right and the men are on the left. And then this looks like this. And these different layers, they represent the different age groups. So the lowermost layer is the youngest population, that is the newborn group, and the uppermost layer is the oldest population. So the pyramid happens because there is high mortality rate and gradually it tapers up because the elderly population are much less. And fertility is high, so newborns are more. So that is why a pyramid looks like a pyramid with a broad base with more newborns and a tapering tip, that is less of the elderly population. But if the older population live longer, then these bars will become bigger and so the shape of the pyramid will change. So I will show you what the pyramid looks like in different types of countries. So this is the population pyramid of the world that I have shown you now. And this is population pyramid of Japan. Japan is a high income country. So here you can see the pyramid. It's not exactly like a pyramid. This double histogram has a different shape. It looks more like a box. So this is a picture of a developed country. So what happens here is fertility is low, newborns are less, child population is less, and mortality is less. Hence, people are living up to older age. So there is a bulge in the middle and it looks more or less like this shape. This is a population pyramid of Ethiopia. Ethiopia is a low income country. So here you can see the pyramid is so distinctly showing here, and the base is broad and the tip is absolutely tapering up. So high birth rate, which makes a broad base, tapering end because there are less elderly population, and it looks like a typical pyramid. This is the picture of a developing country. Now this is the population pyramid of India. So you can see it is like a pyramid only. Base is broader than the tip. The tip is tapering at the end. It looks somewhat like a pyramid, but you can note that there is a slight bulge in the middle. So this is because gradually it is shifting. The country is shifting towards the next stage of demographic cycle, which I will explain after this. So the base is slightly less and there is a bulge above. So that means the fertility rate is falling, and so the young population is less, and gradually there is more bulge in the middle, indicating more people in that group. So this is the demographic cycle I told you about just now. So this is, though it is named a cycle, it is not actually a cycle. It is actually a linear pattern. So 5 stages have been described here, and from one stage to the other, a country progresses as it goes through socio-economic development. So with development more and more, the country progresses from first stage to second stage, from there to third, fourth, fifth stage. So what are these stages? First stage is known as high stationary, when birth rate is high and death rate is also high. Together they keep a stationary population, balanced population, but at a higher level. So India was in this phase till 1920. So this is because high birth rate due to high fertility, unchecked fertility. Family welfare program was not existing at that time. There were no contraceptives or in use at that time. So fertility was unchecked and there were a lot of births. And death rate was also high because there were epidemics, pandemics, there were famines, etc. and people died. So together they made a balanced stationary population at a higher level. So this is the first stage known as high stationary. So next is second stage. So this is named as early expanding. Here birth rate remains high, but death rate starts to decline. Because of developing health services, the death rate, the diseases are controlled and the death rate starts to decline. So when death rate starts to decline, the population increases because birth rate is high, addition is more into the population, and death rate or elimination is less. So the population starts increasing. That is why it is known as early expanding. So India was in this phase from 1921 to 1970. After this, India entered the third stage. So the third stage is known as late expanding. Here the birth rate tends to fall. So family planning program has happened and people are accepting contraceptives. So gradually birth rate tends to fall, starts falling, and death rate declines even further because there's further development of health services and death rate declines even further. So with death rate declining more than birth rate, the population still expands but at a slower rate than the previous stage. So this is known as late expanding. That means population ultimately is increasing in size but at a slower rate. So India is now in this phase. The next stage is low stationary. So here birth rate falls still further and death rate has also fallen. So both are at a low level. And like the first stage, here also they balance each other and the population remains stationary but at a lower level. And the developed countries, USA, UK, Australia, Japan, these are in this stage. Now there is a fifth stage. So some countries enter this stage also, that is declining, when the population starts contracting, reducing in size. Why? Because here birth rate is less than death rate. So addition into the population is less than elimination from the population. So naturally, the size of population decreases. So some Eastern European countries like Sweden, Denmark, Norway, etc. are currently in this fifth or declining stage. So this is known as a demographic cycle. But though we use the word cycle, it is not a cycle. It is a linear one, as I've told you, because once a country has reached the fifth stage, it does not go back to the first stage. A cycle ideally has to be round. So first stage, second stage, third, fourth, fifth, it is supposed to go back to first. So this is not what is happening here. Hence, it is a linear one, not a cycle. It is a misnomer. Now, another concept is demographic dividend. So this is a huge definition given by the United Nations. So that is the economic growth potential that can result from shifts in a population's age structure, mainly when the share of the working age population is larger than the non-working age. So working age is taken to be 15 to 64 years. This is the adult population that is working. Any country, this is by and large the population, we can say, that is working. So they are the productive population, they are the earning population, contributing to the economy of the family and the country. And the non-working age are youngsters, that is less than 15 years and more than 64 years. That is 65, more than or equal to 65 years. So these are the elderly population, these are the young population. So these groups do not work. So they are the ones who are dependent population on the productive or working age population. So what happens when the working population is more than the non-working population? Naturally, there is a boost to the economy. This is known as demographic dividend. And that is growing number of productive people than number of dependents. So more productive people have to support less number of dependents. And this is high in countries with increasing number of young people and declining fertility. So what happens? Why is there so much of a boost? Because there are smaller number of children per household, then larger investment per child. So more freedom of women. This leads to more women in formal workforce and more household savings in old age. Okay, so now I'll describe the world population. So this table shows how the population has been increasing over decades or over a time span. So that means it shows in each row, it shows the time taken to increase the population by 1 billion. So when we started with the whatever documented history is there, in the 1800 there were 1 billion population. So the next billion was added, that is it became 2 billion in 1930. So it took 130 years. Subsequently, the third billion happened in 1960, so only 30 years. Then the fourth billion in 1974, that is only 14 years. So this was increasing at an alarming rate. But subsequently, it has become more or less stable. So in 2011, it achieved 7 billion. So in 1950, there were 2.5 billion population, and in 2019, there are 7.7 billion population currently. So the prediction is that by the end of this century, the global population will reach 11.2 billion. So this is really an alarming condition. So these are trends in 2019. World population, total population, percentage of population under age 15. You need not remember everything here. Just see this and understand what is the picture like. Now, India population, I have told you census happens every decade, every 10 years. That is complete enumeration of the total population in the country. So the most recent census had happened in 2011. So this census data is depicted here. So India is the second most populous country in the world next to China, and it has 2.4% of the land area, world's land area, but it supports 17.5% of the world population. So this is demographic information of India. So this is the total population as per 2011 census, that is 1210.1 million population, and male, female, these are the percentages. So 51.5% male and 48.5% male, female. Then 8.9 under 5, elderly is 8.4, Rural population, urban population 68.8 and 31.2% respectively. Here you need to remember this because this may come in your MCQ for entrance exam. So this gives some Indian statistics. Population, I've already told you, it is the second most popular country. It is the 7th in land area, 2.4% and 17.5%. These figures you have to remember. Density of population is 382 per square kilometer. 382 individuals, people per square kilometer. Average annual growth rate is 1.64%. And the highest populous state is Uttar Pradesh. Okay, now I will discuss some important indicators. So I have told you this earlier session, that is sources of health information, but you can divide it into groups according to various ways. So if we say indirect and direct, indirect census, civil registration system, sample registration system, because those are taken for another purpose. And direct is hospital records, notifiable disease register, IDSP, that is integrated disease surveillance program. These are direct sources directly collected for the purpose of health, and we get data from there. Again, we can say it as divided as population based and institution based. So population based are census, civil registration system, sample registration system, population surveys. These are conducted on population, I've told you. And institution based are hospital records, then occupational data in industries and factories, workplaces, basically pre-placement examination data, periodic health examination data. So those are institution based data. Or we can also divide it as continuous and intermittent. So here you see intermittent as census, population surveys, NFHS, DLHS, SRS, means all these indirect or population based sources. And the continuous ones are those which are happening regularly as a continuous activity. So civil registration system, hospital records, IDSP, these are continuously providing the data and building up the database. So demographic indicators, we have two types, population statistics and vital statistics. Population statistics indicate, these are indicators that measure the population size, composition and distribution. So that is total population, sex ratio, density of population, etc. Vital statistics, these are indicators that measure population fertility, mortality, longevity. Examples are birth rate, death rate, life expectancy at birth, etc. So why do we need indicators? We need to understand the population properly. Why? Because it helps to identify the pattern of demographic events, whether the population is increasing or decreasing, how the composition of the population is changing, etc. We can also identify health factors that can affect the life expectancy of birth. It can increase, decrease, and we can decide priorities in policies and programs that we want to formulate and implement in the population. So some important indicators. So mortality and morbidity, that is crude death rate, age-specific death rate, infant mortality rate, child maternal mortality rate, disease-specific death rate. These are mortality indicators. Incidence, prevalence are morbidity indicators. These I have already discussed in detail in an earlier session. So the next are the fertility indicators. So these are birth rate, general fertility rate, general marital fertility rate. All these I will discuss in this session. And also socioeconomic indicators. These are literacy rate, female literacy rate, level of unemployment, dependency ratio, family size, etc. So here I will discuss the important ones in this session. So vital statistics, it includes crude birth rate and crude death rate. These are known as crude because age, sex, composition is not reflected here. So it is based on the entire population irrespective of the population composition. So this is not used for comparison between any two regions. Why? Because the composition is different. So the death rate has no meaning at all, because a population may have more of elderly people and their death rate may be higher. So another one may have lower. So there may be death rate may be lower. So we compare it, but ignoring the population composition. So that does not give the true picture. So what we do in this case is we convert it into standardized rates. So by means of direct and indirect standardization. And the process of converting this, I have told you in detail, I have discussed in detail in an earlier session how we change it into direct standardized death rate or indirect standardized death rate. So that it becomes absolutely comparable between two nations or two regions, any two regions. So crude birth rate formula is number of live births during the year per 1,000 mid-year population, estimated mid-year population. Estimated because we calculate it, we assess it, estimate it from the census population. And mid-year population is on 1st July, population on 1st July of any year. So from the census population, subsequent years, the births are added and the deaths are removed, so that gives the approximate estimated population. And crude death rate similarly is number of deaths in the year per 1,000 estimated mid-year population. So these rates, these you have to remember. So total crude birth rate is 20, total crude death rate is 6.2. So these, and rural and urban are given. So these rates are, figures are from SRA, Sample Registration System 2020 publication. The reference year is 2018. That means the data is of 2018 and it has been computed and processed and published in 2020. So SRS publications come out very regularly every year and we get updated information. So this figure, these figures, you have to remember. So mortality indicators in India, this gives again from SRS. This is 2016 data, though the crude death rate is for 18 data. So these are the figures. Here again, you don't need to remember everything. Infant mortality rate is important. That I will come to later on. I'll give you more updated figure later on. This is for understanding what the system is like. Now, population growth rate. So annual natural growth rate exclusive of migration. So this is crude birth rate minus crude death rate. So whatever is in between, the figure that comes, that is the addition to the population. So that is the growth rate of the population. This is known as the demographic gap. That is the difference between the crude birth rate and the crude death rate. Annual population growth rate is the average exponential rate of annual growth of the population over a given period. Here you need not know much in detail. You can just remember this because this might come in the MCQ. Population growth rate, it measures how fast the population increases in size and it is not uniform throughout the world. So in Europe, you can see it is less than 0.3%. In Africa, it is about 2.6%. So stark difference. So that means developed countries grow at a slower rate and developing countries or low-income countries, they grow at a more rapid rate. And that is why the difference in the stage of the demographic cycle, where they are placed in the demographic cycle. So in India, the natural growth rate is 13.8 as per SRS 2020. So this shows a picture of the world population. So average annual rate of population change. Now I come to fertility indicators. So all these formula you have to remember, everything. So birth rate, I have already told you about. Number of live births in a year per 1,000 estimated mid-year population. General fertility rate. This is the number of live births in a year by mid-year female population 15 to 49 years. So this is considered as the reproductive age group. Reproductive age group is the group in which a woman is capable of reproduction. So this is considered to be 15 to 49 years. Sometimes it is also said as 44 years, but by and large it is generally 15 to 49 years. So that means in the reproductive population, reproductive female population, this adjustment has been made because estimated mid-year population, not everybody is giving birth. The entire population, every individual is not giving birth. So this is a crude estimate. So what we take is general fertility rate, that is mid-year female population who are capable of giving birth. That means female population in reproductive age group. But there again, everybody is not giving birth because only the married women are giving birth. So we change it to general marital fertility rate. So here you note the numerator is the same. The denominator becomes mid-year married female population 15 to 49 years. Then another indicator is age-specific fertility rate. This is required because throughout 15 to 49 years, the reproduction rate is not the same. Because at older age group, people don't reproduce, don't give birth. So that is why we need age-specific fertility rate for every age group. We divide it into different classes, maybe 5 year, maybe 10 year, but generally we do it for 5 years, 5-year class intervals, and we divide this whole population into different groups, age-specific groups. And now we calculate the fertility rate in each class, in each group. So this is age-specific fertility rate is number of live births in a particular age group, whichever we take. Suppose we take 15 to 19. That means number of live births in the age group 15 to 19 divided by mid-year female population in same age group into 1000. Now again, this is changed to age-specific marital fertility rate because all women are not giving birth, only the married females. So it is the same numerator as this, but the denominator is estimated mid-year married female population in the same age group. Next is total fertility rate. So total fertility rate, this is how it is expressed. I'll explain to you what this means. This means per 1000. So this means summation. I told you sigma stands for summation. That means total. So ASFR is age-specific fertility rate. So this will be different in group 1, ASFR, say first group, ASFR, second group, third group, fourth group. So we total it. And what are the different groups? These groups are 5-year class intervals, starting from 15 to 9 up to 45 to 49. So that means first group is 15 to 19. Second is 20 to 24, third is 25 to 29, so on and so forth, and last is 45 to 49. So all these groups have age-specific fertility rates calculated, and we total all this, that is the sigma age-specific fertility rate of different age groups starting from 15 to 19 group to 45 to 49 group. Now this we multiply by 5. Why? Because we have taken 5-year groups. So we have given one rate for 5-year groups. So that is the average rate for each year within the group. So we multiply it by 5. That means it gives total 5 years for 5 years. So that we divide by 100. So this is total fertility rate. So basically this is the total number of children a woman would bear in the entire reproductive lifespan. Another way is total marital fertility rate, the same thing but age-specific marital fertility rate is considered here. Next is gross reproduction rate. So gross reproduction rate is the same thing, age-specific fertility rate, but only for female live births. So age-specific fertility rate is total fertility rate for all births, male and female together. But gross reproduction rate is only the female births, girl children born. So this gives the reproduction potential, because when a woman gives birth to 2 children, one male and female, the female child will give birth to another offspring. So that is why gross reproduction rate is considered as female live births only. Means the population going through the same age-specific fertility rate as the prevailing rate. But here we do not take mortality. All the girls who are born, all the newborn girl child born, they won't survive because some will die, because mortality also exists in the population. But here we have not considered mortality. So we have another type of indicator, net reproduction rate, which is the same thing, age-specific fertility rate, summation of that between in the reproductive age group into 5. For female live births, considering mortality with mortality divided by 1000. So all these formula you have to memorize. And out of these 2 indicators, I will explain to you because these 2 are very important indicators. So one is total fertility rate. So this is basically the estimated average number of children a group of women would bear if they were to start their reproductive lives at the same point of time and bear children at the same rate as the current age-specific fertility rate in each age group. So basically we have calculated ASFR for the current present population. This is the prevailing age-specific fertility rate for the various age groups. Now we have a group of women. So these group of women, multiple women, hypothetical cohort, so these women will start their reproductive span at the same time. Say all of them start their reproductive life at 15 years and they go through their reproductive life till 49 years and they bear children following the same age-specific fertility rate. Then the total number of children that will be born, as I have told you, it is the TFR or summation of ASFR. Total, that means basically it is the total number of children per woman. In simple words, this is it. This is also known as completed family size. Remember, in this fertility, family size does not mean total number of family members. Family size means total number of children born to a woman, total number of children. Okay, family size means total number of children born to a woman. So TFR gives that completed family size because it is throughout the reproductive life of that group of women. So completed family size or total children per woman. This is total fertility rate. So this is calculated by summing up all the age-specific fertility rates of the different age groups and multiplying that with the class interval I have told you. So now why is this important? Why am I discussing it so much in detail and why it is always discussed? What is the importance? We talk about replacement level fertility. So it means that when total fertility rate, that is TFR, reaches 2.1 children per woman, we have achieved replacement level fertility. So what does that mean? That this is the average number of children a woman would need to have to reproduce herself by bearing a daughter who survives to childbearing age. That means there is one woman, so in the population, this woman will die someday, but she should produce so many number of children so that ultimately, even after whatever mortality is prevailing, there will be one girl replacing her who will give birth to another girl or her own offspring, children. So this is the replacement level fertility. That means one woman is replaced by another woman. So this has been seen to be the figure. This again you have to remember, 2.1. TFR 2.1 is considered to be as the replacement level fertility, and this is what we want to achieve. So what will happen when just it is replaced, one woman is replaced by another woman, the population will become stable. So that is what we want to achieve. So if replacement level fertility is sustained over a sufficiently long period, each generation of population will exactly replace itself. Of course, we do not consider migration in this estimation, in this assumption, but having achieved replacement level fertility, that is 2.1 TFR, and maintaining it for a sufficiently long time, the whole population, each generation will be replaced by exactly same size of population. So this is the importance of total fertility rate. So the next important one is net reproduction rate. So this means the average number of daughters a hypothetical cohort of women would have at the end of their reproductive period if they were subject during their whole lives, that is reproductive span, to the fertility and mortality rates of a given period, whatever was prevailing at that time. So number of daughters per woman. This is again a definition given by United Nations. Simply it means number of daughters a newborn girl would bear during her lifetime if she experiences the same fertility and mortality rates as is there in the population, age-specific fertility and mortality rates as prevailing in that population. So how do we interpret that? NRR less than 1 means population will decrease. That means number of newborn girls, daughters a newborn girl will bear is less than 1. So that means less than her. So it is not being replaced. So this means population will decrease. NRR is equal to 1 means population will remain constant, stable. And NRR more than 1, population will increase. So NRR for India as per SRS 2015 was 1.06. So this is again what we want to achieve. NRR equal to 1 we want to achieve. And how can we achieve this? It has been seen that, calculated that if 60% of eligible couples practice any one method of contraception, then we will achieve this. This eligible couple and methods of contraception I will discuss in another session on family welfare. So these are the fertility indicators, values of the various fertility indicators in India. Crude birth rate is the latest data, and this you have to remember. And these are the others. You go through it. I will tell you the recent data for the important ones in subsequent slides. Next is sex ratio. So what is sex ratio? Sex ratio means number of females per 1,000 males. Females per 1,000 males. So population sex ratio, number of females per 1,000 males. Child sex ratio, number of female children per 1,000 male children in 0 to 6 year age group. Sex ratio is at birth is number of female newborns per 1,000 male newborns in a calendar year. So factors affecting sex ratio. Why do we say separately? We have a population sex ratio, that is fine, but why do we go into child sex ratio and sex ratio at birth? Because it has been seen that these are different from population sex ratio. So why? Factors affecting sex ratio. What are the factors? So difference in male and female mortality. Selective migration. Males may migrate more. And gender discrimination and selective abortion. This is a very important and a very alarming condition. So child sex ratio and sex ratio at birth, I will show you in later slides that these are less than population sex ratio. And these indicate societal attitude regarding gender bias and selective elimination of female children. So sex ratio figures as per census 2011 data. Population sex ratio is 943 females per 1,000 males. Of course, interstate variations are there. This is rural and this is urban. Child sex ratio, you see, it is less than the population sex ratio, 918. Sex ratio at birth is even less, 898 per 1,000 male newborns. So lowest is in Haryana, child sex ratio lowest is in Haryana, you see how low it is, 834, and highest is in Arunachal Pradesh, 972. Then the next socioeconomic indicator, dependency ratio. So this means, the formula is that population, dependent population by the productive population. So dependent population, I have told you earlier, is the younger population plus the elderly population. So younger population means population 0 to 14 years old plus elderly population means 65 or more. So this is the dependent population divided by the population 15 to 64 years. So this is the dependency ratio. This is expressed as percentage. So this can also be broken up into two, that is young age dependency ratio where we consider only the 0 to 14 age group, and old age dependency ratio where we consider the 65 plus age group. In India in 2016, total dependency ratio is 50.54%. So more than half of the population, we can approximate it to half, but a little more than half is the dependent population. Young age dependency ratio is 41.15%, old age dependency ratio is 9.38%. So in the context of dependency ratio, two concepts you have to understand, demographic bonus and demographic burden. So demographic bonus means something good, you understand. So this occurs when there is decline in total dependency ratio due to decrease in fertility. So since fertility decreases, the young age dependency ratio falls, and as a result the total dependency ratio decreases. This continues till dependency ratio again rises due to increase in longevity. So as fertility falls in a population, when you see fertility falls, so young people are less. I showed you the base becomes narrower. So that means the total dependency ratio decreases. But now when the aging occurs, so longevity increases, then the elderly people survive more and old age dependency ratio rises. So again this demographic bonus is obliterated. So next is demographic burden. What happens here? This is a consequence of demographic transition where the total dependency ratio increases due to increase in old age dependency ratio. So as I told you here, rise in longevity, increase in longevity leads to increased old age dependency ratio. And as this continues for a long time, then the total dependency ratio increases. That means the dependent population on the numerator becomes more than the productive population on the denominator. So that is known as demographic burden. So what happens when dependency ratio is high? Higher investments are required for services needed by the young children, the 0 to 14-year age group, and also by the higher age group, that means the older person, 65 plus age group. But there is less income generating population, that is 15 to 64 years. So there is a lot of burden, that is the burden, demographic burden. What happens when there is high young age dependency ratio? Higher investments required for schooling and care needed by children. High old age dependency ratio, we need higher investments for social security and health services. Older people, they suffer from more chronic diseases, and due to increase in longevity, survival is more and the diseases are still there and they are treated. They need to be treated, the chronic long-term diseases. So health services are required. So these require a lot of investment. And low young age dependency ratio results in demographic dividend or demographic bonus, since society has a growing number of potential producers compared to the number of consumers. So next is literacy rate. So first you have to know the definition of literate, and this you have to memorize. So a literate is a person aged 7 years and above who can read and write with understanding in any language. So 7 years is considered because 6 years is considered to be the school going age. So a child starts going to school from 6 years. So after that, the child becomes literate, and hence 7 years is taken as the cutoff for literacy. So crude literacy rate is number of literate persons expressed as percentage of total population in a given year. That is estimated mid-year population. So, but we do not consider 0 to 6 years in the literacy definition. But here the total population includes that. So this is a crude literacy rate. So we have to convert it into effective literacy rate. So effective literacy rate includes the specific age. That means number of literate persons aged 7 years and above per 100 population aged 7 years and above in the given year. So literacy rate in 2011 in India was 74.04%, highest in Kerala, lowest in Bihar. And you can see that literacy rate grew. Decadal growth rate in 2001, it was 64.83 and it has risen to 74.04% in 2011. And this is the percentage growth rate. So this literacy rate, again, this figure you have to remember. So with this, I come to the end of this session. I will sum up what I have discussed. I have discussed demography in the beginning. So there I told you about the definition of demography, demographic process, population pyramid, demographic cycle, demographic bonus, demographic dividend. And I also gave you the world and India statistics. And next I discussed important indicators. So vital statistics, population growth rate. Then I told you about fertility indicators, total fertility rate and net reproduction rate I have discussed in detail and its importance. Then I told you about some socioeconomic indicators, that is sex ratio, dependency ratio and literacy rate. And I have given you figures at a glance for mortality and fertility indicators. So in the end, again, there are some questions for you to check your progress. And the answer keys are given in the end. So with this, I end this session. I hope you have enjoyed this session and I hope you have understood it all. Thank you.